This is the screencast for section 3.3, example 1, logarithmic functions and their graphs. That's right, we're studying logs. Now, remember our stuff on exponential functions in 3.1 and 3.2, y equals a times b to the x? Well, that graph looks like this blue one right here. Log functions are the inverses. They come up and then out and over. Exponential functions, you plug in a number to the exponent. Log functions find exponents. Their output is actually the exponent. It's very hard to picture what a log function is doing versus what an exponential function is doing. So a log function, if you remember, finds exponents. We're going to work on some ways to interpret log functions to help you understand a little bit better what they do. Okay, so for example, what I mean by logs find exponents is that if y equals log base 2 of 16, that means you need to find the exponent of 2 that gets you 16. So 2 to the what is 16? What exponent of 2 is 16? The answer is 4. So 2 to the y equals 16, 4. 2 to the 4th is 16. So the log base 2 of 16 is 4. You're finding the exponent. Now, if we have a chart over here of an exponential function, here's my x values, -3, -2, -1, 0, 1, 2, 3, etc. And then my y values are 2 to the x, exponential function. X is in the exponent. X is in the exponent. I will take 2 to the -3rd and I get 1/8. 2 to the -2 power is 1/4. 2 to the -1 is 1/2. So you can find all of these things very easily. 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, etc. Now, a log function is its inverse, meaning the x and the y coordinates change places, change roles, change relationships. So now your x values are the exponents that you found and the y values are the numbers you plugged in. So your function would look like the inverse of f of x, or y equals log base 2 of x. So you're trying to find the exponents of 2 that get you x. So when I plug in, I plug in 8 for x, I am trying to find the exponent of 2 that gets me 8. When I plug in 4, I'm trying to find the exponent of 2 that gets me 4. Now, if I plug in for x like 3, 2 to the what equals 3? I don't know. That's really messy. So I personally wouldn't plug in 3 for x because I don't know what exponent of 2 gets me x. I'm trying to find those exponents. So if I plug in 1/8 for x, 2 to the what power is 1/8? -3. So the output here would be -3. So as you can see, the x and y coordinates change places between exponential functions and log functions. They are inverses. Alright, so let's look at example 1. Evaluating logarithms. Now these don't have y equals something. We are just simplifying. So in something that's easier for you to interpret, if I wrote down y equals 3 times 5 plus 7, you are just simplifying what 3 times 5 plus 7 is. So you're just saying, well, that's 15 plus 7, which is 22. So we are just simplifying the right-hand side of the equation. That's all we're doing in this example. So A asks, what exponent of 2 gets me 8? So the log base 2 of 8. Well, the log base 2 of 8 is 2 to the 3rd. So I mean, I could technically rewrite this as log base 2 of 2 to the 3rd. So what exponent of 2 gets me 2 to the 3rd? The answer is 3. 2 to the 3rd power gets me 8. Log base 3 of the square root of 3. Well, that's also asking what exponent of 3 gets me 3 to the 1/2 power. What exponent of 3 gets me 3 to the 1/2 exponent? Well, that'd be 1/2. 3 to the 1/2 is the square root of 3. Part C, 5 to the what is 1/25th? Well, let's see. This is log base 5 of 1/25th is 25 to the negative 1. Let's see. Log base 5 of 25 is 5 squared. So really I have 5 to the negative 2 power. So the answer here is negative 2. Is 1/25th. So what exponent of 5 gets me 1/25th? Negative 2. Negative drops it to the denominator, 2 squares it, done. What power of 5 gets me 1/25th? Negative 2. Part D, log base 4 of 1. So it's asking what exponent of 4 gets me 1? 4 to the what is 1? Well, that answer is 0. That answer is 0. 4 to the 0 gets me 1. Log base 7 of 7. What exponent of 7 results in the value 7? The first. 7 to the first power is 7. So simplifying logarithmic expressions. What exponent gets you what you're taking the log of? What exponent of the base gets you what you're taking the log of? The now try problem is number 1. The log base 4 of 4 is what? So it's asking me 4 to what power? 4 to what power equals 4? And the answer there is 1. 4 to the first is 4. 4 to the first is 4. Logs find exponents. What exponent of the base gets you the big number?